Hi everyone, it's Sorkin. Today we have a problem when we are given undirected cyclic graph and we need to find and return an edge that can be removed so that the resulting graph is a tree of n nodes. So what's that mean? So for example, in this case we have 3 edges, and if we are gonna remove, let's say that the edge 2 and 3, right? So in this case it becomes a tree it becomes tree of undirected graph which has no cycles, and in our case we are returning edge 2 and 3 as a result. Let's take the previous example that we have seen and work on it. We are going to solve this problem using union find or disjoint set data structure. So what we are going to do, let's remind ourselves what's the union find, how exactly we are going to implement that. So we are going to for our input, right? So we have 3 nodes. We have node 1, node 2, and node 3. So for each node we are going to create a separate set, so for each one, right? And also we are going to create one more data structure, parent, where it shows that to which set each node belongs to. For example, as we start out, the first node belongs to the parent for the first node is 1, for the second is 2, for the 3 is 3, which means that they all belong to different sets. So now let's find run our 2 methods. The first method is that we do for each our edges, right? For the first edge and for the second edge, we are calling them u and v. So what we are going to do, we are going to run a find function or method which will return us to which set that node belongs to. For example, in this case, for the first one, right? For the first one, to which set first node belongs to. It belongs to the first set, right? The parent for it is 1, and the parent for the second one, it belongs to the second set where the parent is 2. So they belong to the 2 different sets. And the next one is that we are running a union operation where we are joining these 2 sets. Now we are joining 1 and the 2. We can join them because they belong to the different sets, right? And they have different parents. So we are joining these 2, and we are updating this value here of this parent to 2. Now we have 2 sets, 1, 2, and 3, where for the 1, 2, the parent for the 1 is also 2. Okay, so we are picking the parent, the higher value. The higher value here is 2. So now let's go and run this operation one more time. Now we have 2 sets, 1, 2, and 3. Now let's take our next set, right? So our next set is our next edge. Our next edge is 1 and 3. Can we connect 1 and 3? So let's find out. 1 belongs to the set where the parent is 2, and the 3 belongs to a set where parent is 3. So they are different parents, so which means that they are not in the same set, which means that we can join them, right? We can join these 2 sets. That's what we're exactly doing here. We are joining these 2 sets, and now we have only one set, 1, 2, and 3. So now we have 1, 2, and 3, and also we are going to the parent for 2 is the parent for 1 is 2, and we are updating value for 2. We are taking the higher value, and it becomes 3. Now, so we also reviewed this edge. Now let's go to our next edge. We connected 1 and 3, right? We connected 1 and 3. Can we connect 2 and 3? Can we connect 2 and 3? Let's find out. First, we are running the find operation. We are finding a parent for each. Parent for 2 is 3, and parent for 3 is also 3. What it means? It means that they both belong to the same set. The parent is the same for 2 and 3. So we cannot join these 2 and 3, right? We cannot add this edge, because if we are going to add this edge, it will form a cycle. So that's why we are not adding this. We are returning this as a result. If we cannot find any edge, then we are just returning empty array of integer. So in our case, let's add one more rule. The rule here is that if we run our find operation and we find our parent for u, right? For u. So here u and v. for u is equals to our parent v, then in that case we are returning that edge. So for example, in our case we are returning 2, 3. Okay, first thing that we do here, we are creating an array of integer parent with the size of n+1 because we are starting for the first node, right? First node, second node, and so on. And we are setting for each parent. For the first parent, we are setting the value 1, for the 2, for the 3, and so on. The next step is we are going over our edges, and for each edge we are taking u and v, which means that our first node and our second node, and we are finding a parent for them. By finding a parent, we are finding out to which set they are belong to. If they are belong to the same set, it means that there is a cycle and we are returning an edge. If they are not, then we are calling a union function, and in the union function we are joining these two sets. If we cannot find any edge, then it means that there is no cycle and we are returning empty array of integer. In our find function, what we do here, so we are finding parent and we are using path compression algorithm here, and if we are comparing that if the parent is equals to, if it's not equals to our input value to our node, then we are going and recursively calling the find function until we find the parent, until the parent x is equals to x, and we are returning the parent. And for the union operation, we are just setting the value to the, so for example, in our case, as we have seen earlier, right? So for the 1 and 2, we are, since the 1 is less than 2, so we are setting the value for the parent of 1, we are setting the value of 2, and vice versa. What's the time and space complexity of this solution? The time complexity is determined by these two for loops, so it's a 2 of n, so we can say that it's n, and also two functions, two methods that we have, find and union. Both of them are constant. Union is constant, and the find is also close to constant because in this case we are again running the path compression algorithm, and so we can consider that as constant time complexity. So for the space complexity is determined by this array of integer here, which is the size of our input, which is the n. So it's also of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.